Hello, I'm Jay Shetty. I'm going to discuss a topic called network theorems. First of all, we will see the learning objective of this video. Using this video, we're going to learn the basics of the network theorems as well as analysis of the circuit using the network theorem. As we know that there are few theorems used in a network analysis. One of them is the superposition theorems. Second one is the Norton theorems. Then its dual will be a Thevenin's theorems. We will also going to use maximum power theorems to calculate the power transferred to the particular circuit. We will also see the Millman's theorem. The superposition theorem, when we have the circuit with multiple sources, then the voltage or current in a particular branch of a circuit is equal to the current or voltage produced in that branch due to individual sources acting alone. It means the voltage or current in that particular branch is equal to the auxiliary sum of the voltages produced due to effect of individual source acting alone. Since the effect of each source will be determined independently, so the number of times network analyzed is equal to the number of sources present in that network. So this is the superposition theorems. Similarly, we have a Thevenin's theorems. When we have a circuit with multiple sources, multiple passive elements, then that entire network will be reduced or replaced by a one voltage source in series with a resistance. The voltage source will be calculated by removing the load, and it is the voltage seen from the load terminal. The resistance RTH, which is Thevenin's equivalent resistance, is the equivalent resistance seen from the load terminal. As using this Thevenin's theorem, the entire network is replaced by voltage source in series with resistance. So to establish certain characteristics at the output terminal, we can reduce the components, because in our original circuit there may be a n number of resistances or n number of sources, but when we convert this entire network into Thevenin's equivalent circuit, then it contains only a resistance and the voltage. So it is used to calculate the effect on some branch of the circuit with some reduction of a components. This network theorem, Norton's theorem, is dual of a Thevenin ones. In this Norton theorem, the entire network is replaced by a current source in parallel with a resistance. The current generated by current source is equal to the current flowing through the load terminals after short circuiting it, and resistance is the resistance seen from the load terminal after removing it. Now we will going to see the maximum power theorem. The maximum power theorem states that the maximum power is transferred to the load when the internal resistance of the source is equal to the load resistance. Similarly, we have another theorem called a Millman's theorem. Whenever we have a circuit containing multiple parallel branches and each branch containing voltage source in series with a resistance, then that entire circuit will be replaced by a single voltage source in series with a resistance. So this is the Millman's theorems. Now I had given one example. So in this example, we have simply a circuit containing 12 volt battery, 6 ampere current source, and few resistances. Now you have to think that which theorem is more suitable to calculate a voltage across 6 ohm resistance. What you can do, you can take 2 minutes and think over it and write down the answer in your notebook. While while doing this exercise, you can take help of your neighbor. You can cross-check your answer with your neighbor's answers. So this is a simple question, so do not take time more than 2 minutes. Just write it down quickly. So I am assuming that you have done your exercise, so we can discuss the all possible options to solve to calculate the voltage across the 6 ohm resistance. So in this circuit you can observe that there are two sources, one is voltage source and the another is a current source. So what we can do, we can go with our first option, that is the superposition theorems. So what we can do, we can make one source active at a time, that is either 12 battery or 6 ampere source, and other source will be replaced by its internal resistance, that is current source will be open and battery will be shorted. So using superposition theorem you'll get a voltage across the 6 ohm resistance. The second way is that the Thevenin's theorem. Consider the 6 ohm resistance is simply a load. Remove that load and calculate the Thevenin's equivalent resistance and the voltage seen from the 6 ohm resistance terminals. Then that entire circuit will be replaced by a voltage source in series with RTH, that is Thevenin's resistance, and it is connected across the 6 ohm resistance. So you'll get a voltage across 6 ohm resistance using the voltage divider rule. Thanks for watching this video.